So today we're going to talk about functions of any angle. Up to this point we've talked about coterminal angles and how to find them. We've also talked about graphing angles in standard position. So today what we're going to do is we're going to take it one step further and talk about functions of any angle. Up to this point we've also only been dealing with right triangle trig, where we've been dealing with acute angles less than 90 degrees. So now we're going to start looking at what these trig functions, sine, cosine, and tangent, really look like when we are dealing with angles larger than 90 degrees. So starting out, trig functions of any angle. So in lesson 1, we evaluated trig functions of acute angles, which is less than 90 degrees. So now we're going to evaluate trig functions of any angle. So before we do that, we're going to look at the general definition of some of these trig functions. And before we actually do that, off to the right-hand side, I provided for you an x and y coordinate plane that we're just going to kind of build on today to get kind of a deeper understanding of our main trig function. So I'm just going to label my x-axes and my y-axes. Remembering back with our angles in standard position, we know that angles in standard position start with your vertex at your origin. We also know that we start with our initial side on our positive x-axis. So I'm going to start that off here. We also know that we have what's called a terminal side, so the one that rotates around our coordinate plane. And we're going to call this angle here, we're going to just represent it by using theta. Okay, so let's say we have an angle here that's greater than 90 degrees. So let theta be the angle in standard position. And to kind of build on what sine, cosine, and tangent are really going to look like in our x and y coordinate planes, we're going to call some point, we're just going to label some point x and y on our terminal side. Okay, so we're going to pick our terminal side here. I'm just going to label this point, we're not going to give it a value yet, we're going to call this point x comma y. Okay, so let theta be an angle in standard position and xy be any point except obviously the origin on the terminal side of theta. Okay, so before we move on anymore, what we're going to do first, if this is some point x and y on my terminal side in my x and y coordinate plane, I am going to create a right triangle to my x-axis, and I'm going to create a right triangle. If you guys can kind of see that off to the left-hand side. And when I do that, the distance from my point on my terminal side to my x-axis, this distance is going to be represented by whatever my y value is for my ordered pair. From that